All right, welcome back. Here's my solution using 2 pointers for the count unique values problem. So as I mentioned, we use 2 pointers starting from the left, one starting here and the next one, so index of 0 and then index of 1, and then we look forward from there. And then we update the first pointer only at a particular condition, which is when we find 2 unique values, 2 values that do not match. So let's hop over here, and the first thing I'll do is just define my function. Let's call it count unique values, and it will take an array. And let me call it down here with a new list of unique values. So let's do 1, 1, 2, 3, 3. All right, that's good enough, like this. And I'm going to start by making a variable I and setting it equal to 0. So it's going to start right here, right? And then I'm going to make a loop, and this will be a for loop. Let's call it j. And I'm not going to set it equal to 0. I'm going to set it equal to index of 1, which also is value of 1. I hate when that happens, but yeah, index of 0, index of 1. So j equals 1, while j is less than array.length. We don't want it to go any further. And then I++. Nope, j++. So j is just going to go through the entire loop from here to the end. So we have one iteration, and that's it. Now, inside of those iterations, inside of this loop, we're going to compare array index of I and array index of j. So we could just start with that. So array of I and array of j. So what do we want to check? If they are not equal to one another, so array I is not equal to array j, what I'm going to do, first I'll wrap it in valid syntax to make it a conditional statement. If they are not equal, if you didn't watch the entire video where we talked about my approach in the last, the last video, 2 lectures ago, what we do is we compare them. If they are equal, we just move j ahead until we find something that is not equal to what I is looking at. So they're not equal now. We move I up by 1. And then we put this value here. So we don't have to swap them. We just put 2 here as well. So to do that, we just can do I++ that adds 1 to I. So it started at 0. Now we move it up here. And then we set array of I to now equal what is at array of j. And then we move forward again so that j goes up. So now j is 3. This has to be a 2. I forgot to do that. So now j is 3. We compare it. Oh, well, they don't match again. So we move I forward, I++, and we set array of I to be 3. Array of I is equal to array of j. And then the loop moves on. This time they are equal. When that's the case, we don't do anything. J increments automatically because of the loop. So 3 and 3 are equal. So next time through, j goes up to 4. Well, now we have a mismatch again. So we take 4 and we put it here. So first we technically move I up, and then we put 4 here. So now we're comparing 4 to 5. So we do the same thing. We move up, we put a 5 here. Now we're comparing 6 to 5. So we move up and we put a 6 here. And then we move up again. They match, so we don't do anything. Move up again. We put I right here and we put a 7 there. So now we've built up this beginning part of the array that has all the unique values. And it's basically all we want is the length of this portion. And we have that by default. If we look at I and j at the very end, well, j is going to be the very last index of our array. So actually, to demonstrate this, remember this only works with a sorted array, so I can't directly use this array as it is. I need to return it to how it was. So that would be, I don't actually remember it. Let's just say 1, 1, 1, 2, 2, 3, 4, 5, 5, 5, 6, 7, like that. How many unique numbers are there? Well, there's 1, 2, 3, 4, 5, 6, 7. So we should get 7. And we'll call count unique values with that. And then what I'm going to do is in here, let's inside the loop at the very end, console.log I, j. And we have to do it in here if we want j, because j is going to disappear. And if we run it, okay. So we can see, here's I, here's j. And at the very end, j hits the end of the array, and we stop the loop. I is at 6 because that's index of 6. And that's because internally the array looks something like this, where we have all the unique values right here. This is where I is. We can get rid of this. I is right here, which is index of 6. So we need to add 1 to I, because it's basically the length of this section up until I. And we don't want to start at 0. We want to start at 1 when we're counting. So we want to return I plus 1, just down here. Just like this. And if we now test it out, we get 7. And that should be right. Let's try it with something like this, 1, 3. We should get 2, and we do. Now there is a special case, which if we have an empty array, it's not working. It's giving us 1, and it should give us 0. There's no digits in there. And why is that? Well, I starts at 0, and even if none of this runs, and nothing happens in here, we are returning 0 plus 1. So I'll add a little short circuit at the beginning. Just check. If array.length is equal to 0, just return 0. That means there's 0 unique digits. Now we get 0, but if we go back to 1, let's do like this, we get 5. 1, 2, 3, 4, 5 unique numbers. Okay, so that is one way of solving this using 2 pointers, and it's O of n time. It's linear time because we're only looping once, which is pretty nice. All right, moving on.